the storage. And what is the analytics? For example, in the house, you bring many things, but your mother don't cook everything, whatever available. She cook whatever required that time. For example, it is a lunch. Some roti, dal, chawal, and sabji is required. So like that time, the mother has analytical ability, and that is called the analytics. That to choose something which is which can be fit for that time period. And then when you have cooked everything, then you see there is a beautiful lunch prepared by mother, and that is called the visualization. Ah, dal is very good, sabji is very good, looks very good. And that is called visualization. And I will discuss this one. The definition ITU given for the Internet of Things, it is a global infrastructure for the information society enabling advanced service by interconnecting physical and virtual things based on exist and evolving interoperable information and communication technology. You can understand that there are many definitions of IoT, but I have taken this definition because it is so beautiful that if you open the IEEE, there are many different definitions are available. But I like this one very much. It is very beautiful. So we'll go one by one. One is physical, second is virtual. What do you mean by physical? You see a gentleman having a newspaper and he's reading. That is called physical. That you are having the things at your hand and you are experiencing what is that. But sometimes you open a e-newspaper, for example here, e-paper. So you open it and you start reading this one. And this is called the virtual. This is the physical. And virtual and physical. Another example is our online class that I am sitting here physically and I am looking at you, which is virtual. That is once the conscious effort I try to satisfy, I to try to teach something, or I to try to explain something, which you are trying to gain it, but it is virtual. You are virtually situated, and this virtual thing, like feeling, willing, and desiring, is not possible. For example, when I will look at you, I can understand from your face that whether you are this lecture is interesting or not. But now I cannot understand whether it is interesting to you or no. When I am in front of you, sitting physically, and you are sitting in front of me physically, so when you cannot understand, I can try to modify my lecture so that it will be understood by you. But now I cannot see that one. That is why in my class, so we used it to, I took Zoom just to see the face of the student so that by seeing them, you can understand whether they are actually receiving the properly or they are not receiving. But there you can answer. So this is one kind of virtual and physical code. So what are the things around us, everything starting from a mobile, pen, everything all around us are the things. Anything which is connected, and we made many projects. So where I will only show two of the project here. So how the things are connected to the internet, to the cloud, and how it is the analytics takes place. For example, You are a human being. Completely, the sensors and embedded computing in your brain, everything is already attached there within your brain. So as soon as there is a mosquito in your leg or thigh, you will not say that, oh, mosquito is biting, oh, let it. No, automatically your mind, brain will tell. No, no, it will give instruction to the hand that go, there is a mosquito, so you will kill. That's exactly the whole human being is a complete sensor. And that is why the human being has the automatically all things in the human body is connected. Just you think, you don't know what is the blood temperature, but blood temperature is maintained. As soon as you eat food, dal, rice, sabji, but the veins require blood. So blood is transformed into blood. Your bone required magnesium oxide. So that is prepared. So that is what the different activities are going on within your body, but we don't have information because complete things in our body are so complicated and so interconnected that it is very difficult to understand. That is what even nowadays you will find Sophia robot. That robot is speaking and that robot is laughing. That robot also talk and certain topics, whatever you train, but you cannot call that robot as a he or she. You can call the Sophia because she cannot be a male or a gent, a female. Only you can say the Sophia. So let us come here. There are many time we have understood that there was a human to human interaction, and there was then internet came, then the web service came. There are many social media, and then machine to machine interaction. So machine to machine interaction, there are many things. Cisco they have given like Internet of Everything, then World Wide Web, then Skynet, which is the Terminator movie is from there. So if you see when a child take birth, so many people they come to home. Somebody say, oh, he looked like Krishna. So somebody give name Krishna. Somebody says that, oh, his name is Cuckoo. Somebody give Pinku. So many names come initially. But finally, maximum we have two names. One is in school name and another name people call us. So like that, the Internet of Thing also, there are many names, but IoT became the very popular. For example, let us think, we have a house. In that house, there is a chair. And this chair is, in front of chair, there is a table. In the table, books are there, and a laptop is there, and one light is there. So if I want this chair to talk with the computer, I want, because both are the homogeneous, they both are the different object, and they both object, I want them to talk. So if you see this one, what I will do, I put in some kind of some kind of sensor, or for example, I can see you, you can see me. That means the interaction between two eyes. So similarly, I put an eye in the chair, another eye on the computer. So what the chair will give, as soon as, for example, somebody come and sit on the chair, chair will tell, oh, somebody seated here. So he will inform He will tell by using his hand or some signal that the person came and seated here. So that time, what will happen? They will talk each other, and which computer will understand the chair. And that very simple. And then laptop, switch on the laptop, or switch on the, after switching on the laptop, as soon as people come, it switch on. You can see that very simple IoT system. Two objects, they want to talk each other with no human intervention. So that what is benefit? You can save the power, and you can also save most of the time. When you change there are sensors, they can also bring the chair near to you. Like in IIT Kanpur, I have seen there was a professor, so he got a big project. So he made a very beautiful the room. So as soon as you switch on, open the lock, the chair will come near the door, and he will sit there and chair will move. So there are many things. And another objective is here is the light. You can also, as soon as a person sit here, you can turn on the light. And you can put another wheel for this paper and pen, they will also come in front of you. So, or else you can have a current mug. This mug is there, coffee mug, and you set the temperature, you will get exactly coffee at that temperature when you require it. Okay. So that is how the sensor can signal, and that way it can. And sometimes, as soon as a person come, he wanted to open the e-book. So after turning on the computer, automatically it should open the e-book. So like that. So what is that? By using this internet, what we are doing, we are making better living standard of the mankind. For example, one of my student, Nitika, she designed last week, just by putting a human sensor, she can measure that what is the pulse. From the pulse, you can detect whether your health is okay or not. So we are making more in such things. So when you can open, for example, this is a basic IoT devices. These are you can see here, let me, okay. So these are my IoT devices. IoT device is nothing but this kind of sensor. For example, you want to measure in a nuclear fusion reactor. You cannot go with a temperature sensor and put inside fusion reactor and go and measure the temperature. You cannot do that. So what we will do? We will do by using the sensors. The sensor will be measured whatever the parameter you required from the environment. For example, temperature, humidity, gas, everything. And consider that these sensors are supplied from some kind of local energy, okay? Solar, battery, energy harvester, okay? These are if you see, we had a faculty that Dr. Anik Adhya, he was working on the power supply to the micro level devices because they required few megawatt of this one. And this, few milliwatt, they require 3 milliwatt of the power, so they can be generated locally. Okay. For example, like one project long back we did in the Raigad, where Chhattisgarh district, where a lot of Naxalite people are there. So government told us to put IoT device so that we can detect when somebody is crossing and moving in that area, the police can get the information, they can go and catch them in that deep forest. But we put a IPR sensor which detect if anybody moves, it will give a pulse. Like that information comes to the police station. But it was very difficult to connect to any internet because that internets are not available in those places. So these devices, we consider that they are supplied from a perfect source. And these devices, there are n number of devices are connected here in this. Like in your body, you have so n number of sensors are connected in your body. As soon as this you touch any place, it gives directly information to your brain. And according to whether it is good for you or bad for you, the brain gives one output. So when these IoT devices are connected, for example, it is an agriculture field, like one of the speaker, he was speaking about agriculture field. So this is the IoT device, and IoT device send data, and this blue color line is my data. Okay, data is coming. And where it is coming? It is coming to your gate. Okay, for example, in your house, you have a gate also. And this gateway is nothing but a simple computing device. Okay, so gateway, they receive the data. For example, I measure solar intensity outside, and I put a small system gateway, which just they will receive the data and store it. Little storage capability. It is not having large storage capability. And all these sensors, there may be sensor itself is a big class, so we are not going to say about the sensors. And last week I got 37 sensors, whatever available in the world today. I have got all the sensors, and these sensors may be digital or maybe analog. So they sensor processing through this gateway. And gateway has some computing power, and it can also has wireless protocol where he can send to internet also. They have some capability. And then it is connected to edge device. Edge device means interfacing between you and the device, or the edge device between the gateway and the internet. So if we see here, this gateway device, simple devices are Raspberry Pi, Beagle board, then Beagle bone, and addition from an Intel and Galileo-based board. These are available in the market, where these small devices have some, you have small connectivity. There's from here, this gateway, you can directly connect to the internet. And you can have this protocol, okay, internet protocols, the TCP IP or LAN protocol. But from the sensor, we are not directly we are not able to connect directly because it doesn't support these internet protocols. That's why the sensors are not having any internet protocol. So when you have a sensor having internet protocol, your power rating will be very high, and sometimes this sensor delay will be so high that you will get your sensor data after very long time. So that is why, like why we give many times we order to Amazon, because they quick service, within 2-3 days you will get it. And everywhere worldwide you will find that people want quick delivery. Similarly, we do not want a data we are measuring, for example, and it should reach you after even 1.6 microsecond. We do not want. You know that A to D converter, A to D converter, which is today available in the market, they have a transportation delay of 1.6 microsecond to 0.92 microsecond. So this is the delay. Because of the delay, many additive circuit you required to just compensate that delay. So that is why the IoT device doesn't have internet protocol to support internet protocol. They don't have any kind of thing. So what they do, they collect the data, and this blue color, what you are seeing, they collect the data, give to the gateway server. They have connectivity to LAN protocol, TCP/IP. They can connect to the internet. That is possible. And what is that one? They cannot also store large amount of data in the gateway. And that is why what they do, they generally pass to edge device. Because as soon as the gateway have computation capability, start thinking, for example, your father brings something and told you go and give to your mother. And you start opening after your father gave you something, you start opening the box and see what is there inside, and your father will come and give 2 slabs to you. Exactly like father gave you, you go and give to your mother. That is the simple thing. Mother may open whatever she want to do. So this is what authority. They get data and gateway start sending to edge device. And both gateway and both have capability. For example, this is a gateway. Simple computation and processing data is possible. For example, I am getting here the humidity or the temperature. This temperature I sent to the gateway, and gateway I gave that some instruction that show me only through little data, which is you measure whole day. You just give me maximum temperature, minimum temperature, and what is the average. So after computing this processing data, then I put into internet. So I told that, okay, it should be in my. So I send this one through my internet protocol to connected to the internet. So this type of small processing is possible through this gateway. But complicated thing you cannot process here. Because complicated thing when you process, your delay will be very high. So that is this simple process it can be done. So for a complicated process, what we do, if a large number of data comes to you and you give to this earth device, and earth device has intelligent, little more intelligent gate device. So they will process the data, and very complicated data that can be processed through this edge device, and this edge device is then connected to your internet. So this is how this became so beautifully designed. For example, this is an architecture. First thing, we take data from the sensor world. For example, I am taking data from here. This is my data from here, comes to this place. This is sensor world. There are thousands of sensors connected here. And this data comes to this gateway. Then this gateway gives to edge device. And edge device, what he do? He can do little computing if you require. If you don't give charge also to him, just you tell the edge device the large number of data you store in the cloud. So edge device will store in the cloud. Simply, it will follow And then you send, because what you will do with data? Today, data is the money. Money, those who have money, data, they have money. So what you do, the storage, this cloud storage, then you send to analytics. There is a people sitting there. And analytics, he will analyze the data. And after analyzing, it gives back this analytical data. And then these data you can visualize. So this is the way that it moves from, you can say that this moves from sensor, and from the sensor to gateway, gateway to edge device, edge device to cloud, cloud to analytics, analytics to visualization. And then the command. So it is so beautiful. You see, this is the architecture, and the data comes from here, and the sensor data comes, okay? And the sensor data go to gateway, and gateway try to think or give to your edge device, okay? I have not put here edge device, you understand that gateway and edge device there. Then this gateway will give to internet, and internet will tell that please store the data. You store this data, and then you do analytic here, and analyze the data come to internet, and this analysis move to the user. You are the user. So the user and remote user now will give command. Yes, now the soil, for example, you use it in the smart agriculture. For example, in the night, you see that the field became dried and you want to run the pump. So a remote user will see that after analysis, he will get the dryness of the field. So then he will he will order that please switch on the pump. So that is called the command. This green line is a command line, come from internet to the gateway, gateway to each device. This device, the sensor device, when the command comes, then they will give a signal to the actuating device. So this sensor itself and actuated sensor will give an actuating device which will perform the task. So this is so complicated that this complete unit, that you can understand that it is very, very, okay, this complete unit is complete IoT. Today, all over the world, people are working. Maybe some people are doing research, not on this. I don't know how to erase. Okay. Okay. So if you take all over the world, so all over the world, if you see here, the people, they work on the power supply design for this one, that big research is going on, that micro or energy harvesters for the sensor node, and sustainable power supply to the sensor nodes. And this is a big research, okay? If you see in optoelectronic device, and they're working so hard to only the sensor node support of the complete unit, and how the data can be transmitted from the sensor to the node. It is a big research on this one. And second thing, how to receive data through whether it is a wired or wireless. That is also a big research is going on worldwide. That is why this, if you see each point in the IoT, thousands of researchers are working just to improve the communication link between the gateway and the IoT device. And then the communication engineering people study that what is the signal to noise ratio. For example, and when you receive that signal, you signal, for example, Ganga river started from the Gangotri. You go there, you can drink directly the water. When the Ganga river comes and it goes up to meet Ganga Sagar near in the Howrah, so you will see that water is not so pure in that place. So what is happening? Lot of impurity mixed with that one. Exactly when the signal or data comes along with the mixture because it is in ethereal space where the data travel in this in the space. And ethereal space is what? It is nothing but a kind of resonant tank. A resonant tank means you go to a seashore, and when you take bath in a sea, you will see that lot of this sea in the seashore, there are waves are coming. Inside the seashore, the waves are very still, but in the near the seashore, you will find a lot of these waves. And these waves make you, when you stand there, even if you are standing, it will make you up and down because of the influence of the waves. Exactly. When the data travel from one place to another place, the complete space is like a tank, resonant tank. When that passes, sometime it, for example, you are sending the signal for some kind of audio signal. So what it will mix it with the other noise element into that. That is why in communication system, the signal to noise ratio is the biggest factor in the biggest research area. So that way, we get these commands, the data from here. And gateway, there are different kind of gateways, and gateways connecting with Wi-Fi technology, connecting with the Bluetooth technology. While the gateway is connecting through the wired technology, wireless technology, many ways, and more computational capability, and quickly transferring data from gateway to edge device without any delay. So you see, all the device they are developing based on this principle, and that is called the microelectronics design. When somebody design in the microelectronics level, it's a very big way that one of our professor he was telling me that the high computational microelectronic circuit they are developing. So high computation means what? The delay must be minimal and quickly it should process and quickly it has a little computation capability. For example, I can tell you when I was doing MTech, my guide gave me PCL 208 card in IIT Kanpur. And when I put the PCL card, just by measuring one little torque, so only one output you want to measure in a computer, you have to write 70-line program. Nowadays, it is not like that. You just put a Simulink, it will work. So the world is very easier, okay? So this gateway design itself is a big. Then collecting this data and storing it, that is a big data or the data analytics, big data science today, people say that how to store the data, how to save this data, and how to again regain those data when you store. For example, you put somewhere and you go after some time, data are not there. No, if you see, I have not put that place. Data itself is a big, and how to analytics them, that is machine learning, deep learning, artificial intelligence, and then how to train the data. So many things are there in this research. Okay, so I am not going in detail into that, just a basic. Then there are analytics, and then the user interface, the man-machine interface. Man-machine itself is a very big area of research. There are very big area that internet protocol is a very big area of research. So what kind of communication you will do when you have you want a different these sensors. For example, in the Raipur, we put the sensors to detect the human being. If the human being they travel in that jungle, they should be detected by the police. So what we did, we put a detector, and that detector we supplied a battery. The battery, small battery, we put, and it was working fine. But there was no internet. So what you will do? Directly you have a one gateway, you connect to one gateway. That gateway wirelessly it will transfer to another gateway. So you put like that gateway in every 100 meter, and after till you get the source of internet, because in that jungle there was no internet. So how to get the connected to internet? Then only you can put that one into cloud and send to your into for analysis to the user. So what you will do? There may be many gateways. One gateway is connected to another one, till you get the internet. So that is what in a remote place, when these gateways, you can connect so many gateways till you get the internet in those places. And that is what one of the biggest research, that how to interact with one gateway to another gateway. And these are the research are going on. And this is the protocol of the complete unit, that start from the things, and then wire or wireless medium through gateway. There are many gateway routers are available. Okay, from this out router to internet to server or your cloud. Okay. Then what is the driving force? Most of the time, our driving force is that first thing is sensor technology. Today, lot of sensors are available, and this is so cheap, and it is very handy. Just I am showing you a simple sensor card here. You can see it is used for controlling the power in a transmission system. You can see this is a small relay, and these are the power supply. And this small unit can control a big power unit. Okay, this is used for 12-volt relay, you can see here. And this relay is actuated by these sensors, and these sensors are very small. And this is what, very tiny, you require some milliwatt of the power, which can generate from the even the vibration of the nearby. You can have some kind of energy harvester, and that can continuously give the energy to this device. And that is the very important thing actually. And the second one is this cheap miniature computer. Even everybody has a miniature computer, like you have a mobile phone. This microphone was not working. So immediately I connected to my mobile, and it is working now. And low power connectivity, you have a Bluetooth, you have just Wi-Fi, everywhere nowadays there is connection. So low power, capable of mobile device, like drone-based system. So many mobile device you have, you can also, and the power of cloud. So these are the very important things. So if we see the sensor technology, let me show you just one kit of the sensor where you can appreciate the available sensors in our market. This is, you can see here, this is very beautiful, and this is the sensor, you can see here. Okay, and these are the all sensors available in the market, and these sensors you can see that very small. These are the very small sensors, which is the power required is very small. So these sensors are also, it is a, what is sensors? Sensors are device that senses or detect the attribute in the surrounding, okay, whatever there in. And what attribute? Maybe physical or biological or imaging, okay, like video camera, digital imaging, some kind of broadcasting. And the sensor, they sense the data and give to the processor, and processor give to the output devices. When you see here, the first one sensor, I will tell only one or two sensors, other sensors you can read. So you want to create 7-color display. So what you will do, this is the sensor available, which name is KY024. So if you see the sensor, it can produce 7 kind of color. So there are many usage actually. And if you see here, just I am running this video where maybe, yes. You see this video where this sensor just you connect, so you get 7 colors in this. And there are also the infrared transmitter and receiver sensor also, where you generate infrared. And this is one of the sensor, IR sensor, where it can detect the human movement. And I will show where we have used it also. And this is the simple, you can see that this sensor, this gives, okay, this. And if you want to know about transmitter and receiver, you can see here, it transmit, you just give a pulse, this, the transmit, then other side it receive, okay? So this is how this is working, these sensors. So another is a Hall sensor, that this Hall sensor is connected in different ways. And for example, you using as a switching device. Here you see, this is now this lamp is supplied from the main. Now you want to control this one. Now you switch off the main. Now through you want to turn, you on off, it is like a switch, okay? Near Hall sensor you bring, and you see north and south magnet. As soon as north you bring, it turns on, and south you bring, it turns off. So this is what this Hall sensor magnetically it will convert. Okay, the magnetic sensors. Okay. So if you see here, sometime you can measure also what is the magnetic intensity of any. For example, you bring near magnet, you can see that a mini dosimeter when it brings, it can measure the magnetic strength in that one. So this sensor usually the different magnetic materials also, material detection also, and many places. So and there are linear sensors, and all these sensors I have in this box, and this box contains all the sensors here. So then there are RGB sensors, and then ball switches, buzzers. So these IR receivers, microphone, then microphone will convert from the sound to electrical signal, then reed switches, and then tape modules are available, and then heartbeat sensor also. It can measure your heartbeat, and I will show one of our presentation that just now we published a paper in IEEE Hydrocon. So this is based on this heart sensor and then joystick sensor. And this relays we use this in everywhere in our also project because these switches are very intelligent. As soon as you give, it is available up to 300 volt. So if your power supply is at 230 volt, these sensors are very good for that. And then temperature and humidity sensor, especially we use in the solar power estimation and solar power generation capability. In that place, we use these sensors. And there are few light cops, mercury tilt switches. They will detect when they are tilted actually. So that is used in the balancing, okay, when you go take somewhere, whether this surface is balanced or not. That still cheap mini computers are available today. And the mini computer, they can interact, and they're available today by using the mobile and smartwatch, etc. And today, one of the powerful clouds are available. The cloud platform, you can use Google Cloud Platform, Amazon also, they have created a cloud platform where you can store. If you see many IITs, they purchase from Google and they use as a Google server for their, they don't have their own server. For example, IIT Bombay, 50% of their cloud they purchased from the Google. So their email is from through Gmail only. So unlimited cloud they get, and some other IITs also they have purchased, and also Amazon also they are selling. So these different objects when we are connected, and we need to design like this protocol. So what is this? This means your user interface. For example, you can see that what is the hot water temperature, okay? This temperature you can see visually, and you can set the temperature and the living room temperature, for example, you set it to 21 degree. So it will automatically control the compressor so that it will give you 21 degrees centigrade. So like that, the storage platform, you can store all the data of the living room, kitchen room, solar temperature, bedroom temperature, everything you can save, and that can be analyzed or visualized. For example, I am measuring our IIT Patna, what is the daily power consumption. So if you see here, these are the kind of the data where you get a whole day like this data. But in analytics, for example, you want maximum and you want minimum. So what is our requirement? Our requirement may be the maximum temperature or the minimum temperature or average of this one. So that is our requirement. So that is how one can easily understand the data, that data can be stored. So you need not to store all the data. For example, here. So you need not to store all this data. You can store the average data, for example, maximum data or minimum. So there are many opportunities to be connected to the IoT, and these IoT are visualized and very beautifully integrated with the industries and vehicles like charge protocol. Like you have an electric vehicle and you have a community and how they will charge. At a time, we don't want because it will be highly loaded on the grid. So you need to charge shift wise. So how to charge that? That is called the optimized protocol of the charger. And second thing, the retail. So if you go to Amazon, they have all the robotics they have employed, and you give the list to them. The robot will collect everything and pack in a box. And the user, give to the packing people. Packing people will pack, and just they will send this one. So this is today very perfect actually. Even medical devices are completely used. In IIT Patna, you can see this is our solar tree. So one of the application is that this solar tree is very smart. So this solar tree, if you see here, and this solar tree, as soon as it is smart, lights are used here, and this is our, you can see here, just this. Okay. So you can see this is our IoT device. This is, you can see here, this is the router, Zigbee router, and this is the Arduino. Okay. And they are the voltage sensors. You can see this is the current sensor, and this is my voltage sensor. And there are also sensors connected here for detecting. You can see this solar tree, we have all this wiring comes from here inside and come to here. And the solar tree, because we want to remotely control the solar tree, complete small solar tree was designed. And as soon as you can see here, we have a LDR module where it will show the intensity, okay? The LDR module will show you the intensity of light. So you can measure the insolation from here, then you can predict how much power produced by this solar plant, okay? 200 watt. And within this solar tree is our battery, charger, everything is connected here in this solar tree. And another, this IoT device, we have usually in this Toipur village, there is a village and we have a AC/DC microgrid. It is in the Boisali district of the Bihar. And this project was sponsored by General Electric Bangalore. And here you can see that this is the place where we used this is our IoT device where we install. And this what is, we have a solar plant, then we have a variable DG, okay, diesel engine, okay, which produces the alternator connected to alternator and the alternator. And we have a battery here, it says, and this complete unit. It's IoT based communication system because the people, they don't want to stay in the village. And another, we have the smart wind solar microgrid in IIT Patna. You can see we have a wind turbine and we have a solar unit, and they're connected through this complete unit. And then these are the communication protocol. where you can design your own communication protocol. And these are the gateway device. Okay, so there are for 10 gateway device, you can use any number as you like. Okay, then these are the different protocol you can design. So this is we got this project around 3 crore 300 lakh project, the smart and smart grid. Another project is Imprint Project, which is a software tool for planning and design of smart grid. And this project is sponsored under Imprint, and the software part is designed at IIT Kharagpur. Another part of the software is designed at IIT Guwahati, and the hardware is designed at IIT Patna. You can see here, there is a horizontal wind turbine and there is a vertical wind turbine. The horizontal wind turbine, they are operated at a higher speed, wind speed, and the lower wind speed, this vertical wind turbine can connect. And it is connected with a DC solar microgrid, this solar tree, and this solar tree, both are integrated here through this controller. And after this controller, this given to the smart electric loads here. You can see these are the electric loads. So complete unit we have fabricated here, and beautiful. It is one of the best, one of the good project in this. Then we have a smart transmission line under grid penetration. For example, we have solar wind farm, we have solar, and we have grid. And these are the smart meters where this feeds power to the industrial load, to a household load, and to a agriculture. So this we want that this will be controlled very smartly. If you see here that how we control here, this is our laboratory. We developed a smart transmission system. You can see the power comes from here, and there is a smart switch here. And here, these are the smart switches, okay? And then it goes to the transmission line, one terminal. And the transmission line, you can see, these are the inductors and capacitors are connected here, you can see. A small model of a transmission system, and it is goes from a long transmission system, a medium transmission system, a short transmission. You can do any kind of transmission system. Then it goes and feed to the load here. Okay, you can see. So if you see, this is our simple, the mobile based, okay, you have a metering system. You can measure in the app-based metering system here, and you can control all switching, braking system also. You can design by using your simple mobile only. So this is how the smart energy, and this is the one of the best project in the Imprint, which was displayed in the ministries in Delhi. And you can know that this is a very, this video you can see that my student is explaining that how this is you can see the receiving end voltage is more than the sending end voltage. That means there is a ferrant effect in the transmission line. And now, even if you can apply the fault condition, and automatically fault condition can be cleared, or it will isolate the line also from the main line also. This complete unit was displayed in the grid tech also. So we got also very nice around 1 lakh rupees for a award for this one. And there are also IoT solution for the home. And this is our smart home. There we developed this smart home. You can see here, it is supplied from the solar. You can see this is our solar unit, and this power supply comes here, and there are chargers. Okay, that chargers, they charge the battery. Here you can see this is the battery. So this is our living room, and this is our kitchen. So this is a corridor. You can see here, this is a detection camera, okay, like IPR sensor. As soon as somebody enter in this corridor, the living room, if the temperature is set, so it will automatically turn on this fan and automatically switch on these lights if somebody enter here. And automatically the living room, this power supply will be on for other devices. And the kitchen area also, if you see, there is some problem in the kitchen area. There are the sensor here. You can see it will detect if there is a gas leakage. So it will detect and inform. And there is an exhaust fan here, which pushes this exhaust fan will take out all this leakage gas in this room. And beside, backside is your complete energy management area, where it will only taken care of all the power supplies and turning on, turning off, and all the storage, okay, battery storage. Exactly like in our, we keep backside our brooms, everything. Whenever required, we brings from there. Exactly, there is a store in the backside, and this is the corridor. So this is the design. If you can see here that this is the complete design of the smart home. You can see here it is designed by Om Smaran, one of my student, and because the this is a small model. You can see that in the computer also, you can see all the temperature, humidity, everything you can measure from here. And even by using your mobile also, we developed an app by which you can turn on everything, switching on bulb, LED fan, just simply by using cell phone. So okay, so these are the few applications. There are many applications also. If you see Copcape, London Heathrow Airport, it will inform to the maintenance crew if there is any problem also. And nowadays in the underwater actuating system also, underwater things also. And then Internet of underground things also by like mining, detection, everything you can do. And Internet of battlefield, okay, how to use the different cameras and detect, and accordingly there will be fighting without any human being also. And Internet of space also, and Internet of nanotechnology. So today's challenge is that big data analytics. So I'm not going in detail, and those who are computer scientists, they know better than me actually. So connectivity, how all the sensors are connected, from starting from Bluetooth, Wi-Fi, everything, and then the mobile system and sensor, wearable energy harvesting, security, and privacy. So now research community in the IoT, mobile system, sensor, real-time system is one of the important things. And then human computer and machine learning, data mining is another thing. And communication protocols, every day, the communication protocols are improving day by day because of the rejection of the noise. They have capability to reject the noise. That is mostly focused here. And compact size, low power utilization. I remember the DSP processor which we used to get long back, it was 5.5. But now you see the DSP processor, they are 3.3 volt. That means they try to reduce the power required by these devices. And then there are big networks also, a wireless sensor network. Then then another is what is the internet protocol, how to use it, and gateway, all these things are another kind of research. And another big research is going on the security and privacy. So you turn on and somebody will come and turn off. So how to ensure that one? So this is called the security. And then intelligent data processing system. So how the query, discovery, data, so classification, clustering is a big field of research. So all the people can actually, there are many, and I have not put here, and there are many data that are how to detect that those data. And that is why today multimodal and heterogeneous data analysis is one of the biggest. The noise and the time and location dependent. The data are time, dynamic, and varieties in the varied in quality. And there are many things. Okay. So thank you very much for this for attending this talk. If you have any questions or comment, I'll try to answer if I know that one, or else I will answer you. I'll mail you. Okay.
Thank you, sir. Thank you very much. Informative session. One of the participant has asked, during use of internet, what to do to avoid the risks?
First thing, we should, when we design an internet, IoT, you just interact between two devices, and the interaction, first thing is you have to keep safety. For example, we put in the Toipur this IoT device, and one day we have not got any data. So we thought that something has happened. So when we visited to that site, we saw that there was no generator power because of they didn't put any petrol. So how diesel? How the generator will run? So what they did, they removed this IoT device. They have beaten that IoT device to the ground 3-4 times. So one, two component already broken there. And that is why we didn't get anything. So when we went there, we saw that why these are the somebody has broken this thing. Then I asked that who is in charge. He told, no, many people came. They thought that if we will beat like this may work. I told you have to put diesel in your generator, then it will run. Not to why you touch this side. So this is the problem in India. That's why knowledge and proper security is very important. And first thing is you make a case and put a lock so that the material are safe. Now, second one, who will access? Give a code. Each device you give a code to unlock that device. So you give a code, in that way you can have security. But here we have not used any such things in IIT Patna because it is our laboratory. We only know others. They don't come and interfere. Okay. Hello. Hello.
Udaya sir, your voice is not coming. Sir, Udaya sir voice is not coming. I think he is muted.
Nitin Rastogi ji.
Yes,
Nitin
sir.
Rastogi ji has raised his hand. So Nitin Rastogi ji, please put your question and unmute your mic.
Okay, sir, I have unmuted my mic. Can you hear me?
Okay. Please,
Yes.
please put question.
Yes.
Okay. Good morning, sir. Sir, we developed a project for Arunachal Pradesh government for finding the cattle in rural areas, which was near to the China border. We implemented the project, but the main problem was that we didn't have any network communication at that point. GSM was not allowed in the China border area, so mobile network is not available in that area. So when you were implementing a project in Bihar state in a village, then how were you able to transmit your data from that equipment to your main server? Did you have the GSM network or you were using some other network?
So actually, what we are having here, the internet is available those places. So through wireless protocol, we used TCP/IP. Okay.
Okay, sir.
So
Okay.
there it is available internet, but in Chhattisgarh, it was not available. So we used to have one gateway, then another we transfer to other gateway, from there another gateway, from there another. After 500 meter, I think we got the internet connectivity. So
Okay.
there we put.
Sir, we are working on LPWAN, that is low power wide area network, the network that is being used by IoT devices. Sir, do you feel Zigbee or this LPWAN will work for our project? Because we have to implement in Arunachal Pradesh area as early as possible.
No, that may not work because your distance is a little high. I have not put here what kind of protocol. But another slide I had long back. So you need to know that where you will put which device actually.
Sir, our device is moving device. So it's not a stable device. Since it's not a cattle, तो cattle तो move करती रहती है सर पूरे एरिया में. ऐसा तो नहीं है वो खड़ी रहेगी. तो वो कैटल मूव करती रहेगी, तो हम स्टेबल नहीं रख सकते अपनी डिवाइस को. हम ये नहीं कह सकते तो इस एरिया में रहेगी तो हमारा नेटवर्क की लिमिटेशन नहीं है.
Yes. So you can do one thing. that at least you can have some kind of this router nearby, because kettle area is already, within this area. Then you can use routing device for this type of information communication.
Okay, sir. Can I communicate? Can I communicate to you later on if I'm working on that project?
Yes, yes. You are working anything you required, because we implemented many projects in the rural places also.
Okay.
So you can connect.
So because this router property of repeating our routers at a distance was not allowed to us, since it's a China border and army didn't allow to use Wi-Fi in that area. We had so many limitations. So we were thinking about something new. That is LORA, LoRa network. You have heard about
LoRa,
it?
yes, yes.
So we are using that one, but we are facing some problems, since in India it's available, but there are many limitations to it. So I was thinking, can we discuss to you later on this topic?
Yes. Yeah,
Okay, thank you, sir. Thank you, Udaya sir.
Okay.
Udaya sir.
Thank you very much,
Thank
sir.
you.
Thank you for the so much informative session. And I think no more participant has raised some questions. So thank you finally. Thank you.
Okay, thank you.
Udaya sir, can you share the sir's email ID? So because he has told that we can talk to him. You just share me his email ID so we can work on it.
I will request you to mute your mic and we will talk regarding this on WhatsApp. So I am going to invite our next speaker.
Okay.
Thank you for your question. So, respected participants, so our next speaker is Professor Jimthan Maithu. So, Professor Jimthan Maithu is Associate Professor in the Department of Computer Science, Indian Institute of Technology, Patna. He has published 64 research articles and 145 conference papers. Dr. Matthew has also authored 4 book chapters and 3 books. Dr. Matthew will introduce the architecture of IoT and other related contents. So, welcome, Dr. Jimson Matthew, sir. Are you hearing us?
Yes,
Dr. Jimson Matthew, sir.
For introducing.
Thank you, sir. Please.
Can you hear me?
Yes, sir. Yes, sir. You are audible.
Okay, let me share the screen, please. So good afternoon. Can you hear me?
Yes, sir, you are audible.
Okay, so I just now I listening to Professor Behera, and he has given quite a bit of background about Internet of Things. What I plan, whatever I plan to cover, also he has covered a little bit, so there may be some overlap. However, if you know these things,